Alright, in this video we're going to talk about Unit 5, Objective 1, finding limits graphically and numerically. So, limits, the idea of a limit is going to be the building block to all of calculus. Everything that calculus is based on limits. So while there is a formal definition of a limit, AP exam's never going to ask about it, so we're not really going to use it. We're going to kind of get by with an informal definition. So as far as we're concerned, the y value, a limit, is the y value that a function approaches as we get closer and closer to a certain x value. And this is going to be on both sides. Right? So on both sides of that x value, we want to see what y value we are approaching. Now note, we don't actually care what the y value is, just what it approaches. So if we have a hole in the graph, I don't care where the closed circle is, I just want to see what I'm getting closer and closer and closer to. Now our notation is going to look like this. We're going to say the limit as x approaches some value c of f of x. And that's going to read the limit as x approaches c of f of x. So there's our notation. Now there's going to be many ways we're going to do it. Most of them are going to be algebraic, but today we're only going to look at graphically and numerically. So graphically, we're going to look at these two things. So we have two graphs, the graph of f, the graph of g. It's kind of hard to see, but we have like a line right here as part of the function. The other lines are pretty easy, or a little bit easier to see. But there's 5 problems here that they want us to find. So if we look at number 1, it's the limit as x approaches -1 of f of x. So here's f, so we're going to look at the graph. Now they're saying the limit as x approaches -1. So this is the value that we want to be getting closer to on each side. And then we want to find out what y value we're getting close to. So as I get closer and closer to -1 from this direction here, I'm approaching a y value of 1. As I get closer and closer to this x value of -1 from the right-hand side, I'm approaching a value of 2. So since I'm not approaching the same numbers, right? So I'm approaching 1 from this angle, or from this side, so kind of going to that value 1. As I'm coming from this direction, I'm getting to 2. Since it's not approaching the same number, we're going to say that this limit does not exist. Now looking at 2, it's going to be very similar. The limit as x approaches 1 of f of x. So now we're trying to go to this x value of 1. So as I come in from the left-hand side, I'm going towards a y value of 1. As I'm coming in from the right-hand side, I'm going to a value, 2 up here, going to a value of 0. So 2 from the left, 0 from the right. They're not meeting at the same point. We're not approaching one single y value. And our limit says the y value that we approach. Now on G, if we look at number 3, it's going to be, we're actually going to get an answer this time. So as we're coming into -1 from the left-hand side, I'm approaching a y value of 1. As I come in from the right-hand side, I'm approaching a y value of 1. So both of these little arrows are kind of pointing at the same y value. Now notice, our answer here is going to be 1. Notice that the actual function value, we have a closed circle up here at 2 and an open circle here at 1. We don't care what the y value is. We just want to know what the y value is getting really, really close to. So another way to kind of think about this is if we were to put an imaginary little line above all of this x value of -1. And I were to say, given just what you see here, what do you think the y value is going to be? Well, it looks like the y value is going to be 1. So that's what our answer is going to be. If we tried that over here, and I said, what does it look like the y value is going to be here? You wouldn't be able to tell me, because it's coming down here and it's coming in from up here. So we don't really know on this one what the y value should be, but here it's clear as day what the y value should be. Now, that's not what the y value turns out to actually be, but again, we don't care what the y value actually is, just what the y value looks like it should be. So looking at G as x approaches 1, well, we're going that way. So I'm getting really close to, I'm approaching -1 from the left, I'm approaching -1 from the right, so our answer here is going to be -1. So again, if you wanted to think about if we were to put a line covering up that x of 1, and I were to say what y value does it look like I should hit, Well, it looks like I should hit -1. And it turns out in this case that we actually do hit that. But again, it doesn't matter what the y value actually is, just what the y value should be. Now, this problem here, I just kind of threw this one on here to show you really quickly a property of limits that we're going to use later, but kind of show it to you now. If we have a sum inside our limits, it's going to work the way you think it should. We can break this up into two different limit problems. This is -1, yeah, -1 of g of x. So it's going to work the way we think it should. And since this first part here we already found doesn't exist, and we already found that's going to be equal to 1, does not exist plus 1 still doesn't exist. But I just kind of wanted to throw this on here to show you that limit properties work the same way as derivative properties. If we have a couple things added together, or I'm sorry, integral properties, not derivative properties. If we have a couple of them added together, you can split it apart into two separate limits. So we have two more real quick examples, both of which are numeric instead of graphic. So this says use the table to find the given limit. The limit's going to be as x approaches 0 of this function here. So if you were to put all of those values into a calculator into this function here, right? So this function down here, we're going to get the following points out. We're going to get 0.29111, 0.2889, 0.2887, 0.2886, 0.2884, and 0.2863. So what we're really thinking about here is turn this into a graph in your mind. So if we think about what this means, it's as we get really, really close to the x value of 0, what does my graph look like? Well, 0 is going to fall right in between these two numbers. So 0 is going to fall right there. So if I am on one side of 0 at the point 2.887, and here I'm at the point 0.2886, keeping in mind that our answer needs to be correct to 3 decimal places, well, it looks like I'm at the same number, right? So when we looked at the graph before, it's going to be pointing at 0.2887. It's going to be pointing at 0.2886, but both of those numbers, if we go to 3 decimal places, are 0.289. So if we were to think about a graph, they're both going to be pointing at the same y value, right? These are only, what, 1,000th apart on the x-axis, so they're really, really, really close to each other. So our limit here is going to be equal to 0.289. So again, what y value are we getting really, really close to? Well, both of these are really, really close to 0.289. That's what we're kind of looking at with a numeric problem. So one more. Sometimes we're going to be asked to find a one-sided limit instead of just a limit in general. So these are simply going to be asking you what the y values are approaching from the left to the right, but not both. So if we went back to that first graph that we looked at, we were trying to figure out from each side, what am I getting close to? On a one-sided limit, we're only looking at one side. Our notation is going to be like this. We're going to say the limit as x approaches c. If we put a little plus sign as an exponent, that's going to be from the right. Or if you want to think about it as from the positive side, so moving in from the right. From the left is going to be very similar, but we're going to put a little minus sign up there. So that one's going to be from the left. So on this problem, we want to find the limit as x approaches -1 of f of x if this is f of x. So x approaches 1 from the left. So if we're thinking about a number line, there's 1. I want to pick numbers going this way. So we're trying to find the y values that this function is approaching as we get really, really close to 1 coming from this side. Well, our table, we're going from 0.8 to 0.9 to 0.99 to 0.999 to 0.9999. So we're getting really, really, really close to this 1. So we're going to try to find what y value we're going to get really, really close to. So again, if you put these things into your calculator, you're going to get 2.44. you're going to get 2.71. You're going to get 2.9701. You're going to get 2.997. And then you're going to get 2.999. So as I keep getting closer and closer to 1, the y values are getting closer and closer to a value of 3. So that's going to do it for this video on limits. The big thing to keep in mind is we are trying to find out what y value we're getting close to, not what y value we actually are. So that'll do it in the video. We'll see you in the next one.